Good morning, dear students. Our lesson today is probability. In our daily life, we always expect events that may happen and may not happen. An event is either certain, possible, or impossible to happen. Certain event or sure event, it means that it must happen, as the sun rises from the east. The possible event, it may happen, as it may rain tomorrow, and it may not. The impossible event, it never happens, as a cow will fly. Can the cow fly? No. So it's impossible to the cow to fly. So it's impossible event. It will never happen. Calculating probability. The probability of the impossible event equal 0. The probability of the certain event, sure it will happen, this event sure will happen, it's equal 1. The probability of the possible event, it lies between 0 and 1. It means it's going to be a fraction. More than 0 and less than 1. The sum of probabilities of all possible events equal 1. The probability of an event A, for example, probability of A, any event, equals the number of ways event A can happen over the total number of possible outcomes. For example, we have a box contains 4 blue balls, 2 red balls, 3 green balls, all equal in size, or we can say they are all identical. If a ball is drawn blindly from the box, what's the probability of drawing a blue ball? The blue equal 4 balls, and all the possible events is the total number of balls I have inside the box. The total number, 4 plus 2 equals 6, plus 3 equals 9. So the probability of drawing a blue ball equals 4 over 9. Again, the probability of drawing a red ball. How many red balls do we have? 2. Excellent. Over the total number of balls I have, which is 9. The probability of drawing a green ball. Do we have a green ball here? Yes, we have 3 green balls. Over the total number of balls I have, which is 9. But wait, this time I cannot leave the fraction as it is. Why? Because in the probability, I have to find the fraction in the simplest form. So here I'm going to divide 3 divided by 3 and 9 divided by 3 equal 1 over 3, or third. Search for 3 and 9 in which table? In table 3. So I'm going to divide 3 divided by 3 and 9 divided by 3. Excellent. Now again, probability of drawing a non-blue ball. What's the meaning of non-blue? It means I don't want the blue balls. So I'm going to cross the number of blue balls and count the rest. The rest are 2 and 3. 2 and 3. So the answer is going to be 5 over 9. Or I can say all the possible outcomes from the box is going to be 1. Excellent. 1 minus the blue balls are how many? 4 over 9. So now I'm going to subtract 1 minus 4 over 9. This time I'm going to cross the 1 to write a fraction instead of it. I'm going to write 9 over 9. Then I'm going to subtract 9 minus 4 equals 5. And the denominator, I'm going to write it as it is. The last question, probability of drawing a non-red ball. Again, I want to cross the two. I don't want the red balls. I want the rest. The rest are 4 and 3. 4 plus 3 equal 7 over 9. Or I can say that 1 is the whole possible events will happen in this example. So 1 minus non-red, it means 2 over 9. Then I'm going to cross the 1 again and write a fraction instead of it, 9 over 9. From where I got the 9? From the denominator. 9 over 9. Then I'm going to subtract the numerator. 9 minus 2 equal 7. And the 9 in the denominator, I'm going to write it as it is. We have another example. If it's going to ask you if the probability of a student's failure is 0.2, then the probability of his success is, again we said, all the possible outcomes in any experiment is 1. So I'm going to write 1 minus 0.2. And the rest, which is the probability of his success, equal 0.8. Now, in an experiment of tossing a single dice once and observing the number on the top face, we all know the dice? Yes. Do you know the numbers inside the dice? We have numbers from 1 to 6. 1, 2, 3, 4, 5, and 6. Now, the probability of getting the number 5. How many 5 do we have inside the dice? Excellent, we have only 1 5. So I'm going to write 1 over, what am I going to write down? All the possible outcomes are the numbers from 1 to 6. So how many numbers do we have? We have 6 numbers. So all the possible outcomes, or the total number of outcomes, is 6. So I'm going to write 1 over 6. The probability of getting an even number. Now, you have to remember, what are the even numbers? 0, 2, 4, 6, 8, 10, and so on. So, the even numbers inside the dice. The dice contains numbers from 1 to 6. So, the even numbers inside the dice, 2, 4, and 6. How many numbers do we have? 3. 3 over all the possible outcomes is 6. Excellent. And don't forget, I cannot leave the fraction as it is. I have to simplify it. Search for a number. I can divide it by 3 and 6 at the same time. Super. I'm going to divide by 3. 3 divided by 3, 1. And 6 divided by 3 equal 2. Again, the probability of getting an odd number. Remember, the odd numbers are 1, 3, 5, 7, 11, 9, 11, and so on. Now, how many odd numbers do we have inside the dice? We have 1, we have 3, and we have 5. So how many numbers do we have? 3 over the total number of outcomes, 6. And again, I'm not going to leave the fraction as it is. I have to simplify. Search for a table. 3 divided by 3 and 6 divided by 3. So it's 1 over 2 again. Or half the dice is odd. So half the dice is even and half the dice is odd. Number 4, the probability of getting a number greater than 6. Greater than 6. Is there any number greater than 6 in a dice? Of course no. So the impossible event, it will never happen. So it's 0 over 6 and it's equal 0. The probability of getting a number less than or equal to 6. Concentrate here. Numbers less than 6. Yes, we have 5, 4, 3, 2, and 1. But or equal to 6, it means I'm going to start with 6. So we have 6, 5, 4, 3, 2, and 1. How many numbers do we have? We have 6 numbers over the total number of outcomes we have. 6 over 6, any number divided itself equal 1, which is a sure event or certain event. The probability of getting a prime number. Remember with me, the prime numbers are the numbers that has only 2 factors, 1 and the number itself, and the prime number starts with 2, 3, 5, 7, 11, 13, and so on. Now inside the dice, how many prime number I'm going to find? I'm going to find the 2, I'm going to find the 3, and I'm going to find the 5. So how many numbers do we have? We have 3 numbers. Excellent. 3 over 6. And don't forget, you have to simplify the fraction in its simplest form. So I'm going to divide 3 and 6 divided by 3 equal half. So I can say that half the dice is even, half the dice is odd, and half the dice is prime. Number 7, the probability of getting a number divisible by 5. What's the meaning of divisible by 5? I can divide it by 5. How many numbers I can divide it by 5 inside the dice? Of course, only number 5, and I can divide it by 5. So how many numbers do we have? 1 over 6. The probability of getting a number divisible by 2, it means I can divide this number by 2 from the numbers inside the dice. I can divide the 2, I can divide the 4, and I can divide the 6. So how many numbers do we have? Excellent, 3. 3 over 6, and again, I'm not going to leave the fraction as it is. I have to simplify it. Search in table 3 and 6. They have the same number, yes, divided by 3. Excellent. And the answer is going to be half. The last question, the probability of getting a number divisible by 3. In numbers from 1 to 6, which numbers I'm going to divide it by 3? I can divide the 3 and I can divide the 6. Excellent. So how many numbers do we have? 2. 2 over 6. And I'm not going to leave the fraction as it is. I'm going to simplify it. I'm going to divide the 2 and 6 with, excellent, divided by 2. 2 divided by 2, 1, and 6 divided by 2 equal 3. So equal third. And your homework booklet, page 43 and 44. Thanks a lot.